What's up guys, and welcome to this video. This is a walkthrough of question 9 of the 2017 IEB AP Maths exam. So this question is on integration. Okay, so from our formula sheet, these are just two notes that may come in handy. Basically, the derivative of tan squared theta equals sec squared theta, and 1 plus tan squared theta is equal to sec squared theta. Both of these can be found on our formula sheet. Okay, so we start question 9 and we look at question 9.1a. Okay, so basically it says it is given that sec to the power of 4 theta is equal to sec squared theta tan squared theta plus sec squared theta. And we're told to prove the identity. Okay, so we start off by stating what the left hand side is. That is sec 4 theta. Okay, and then the right hand side is equal to sec squared theta tan squared theta plus sec squared theta. Okay, so we can pull out a common sec squared theta, and we're left with tan squared theta plus 1, which is obviously equal to 1 plus tan squared theta. So that whole term is equal to sec squared theta from this identity. Okay, so we can say that the right hand side is equal to sec squared theta times sec squared theta, which is equal to sec to the 4th theta, which is equal to our left hand side. Therefore, we have proven the identity, or proven the identity, and we get 4 marks for that. Okay, part B says, hence, or otherwise determine the integral. Okay, so we want to determine this integral of sec to the 4th theta, which we have proven to be the integral of sec squared theta tan squared theta plus, all of this is in brackets, plus sec squared theta, okay, d theta. Okay, so we can separate this to be the integral of sec squared theta tan squared theta plus the integral, let's get that right, d theta plus the integral of sec squared theta d theta. Okay, and now we can work with these separately. Okay, so let's take a look at, okay, so first of all, we know, okay, so we can solve the back end of this, the integral of sec squared theta. So if we integrate both of these, is equal to tan squared theta. So this is equal to tan theta. And that is actually sec theta. The derivative of, there we go. The derivative of tan theta is sec squared theta. Okay, so that's looking better. So now we have sec theta. Okay, so that is the derivative of the second part. So now we have to look at this part right here. And to do that, this is a very interesting thing, because what we have here is we have basically a product rule. So what we want to do is that we can use this same note before, but instead of tan, what if we used tan, so you have to look for a pattern, tan cubed theta. Okay, so if we use tan cubed theta, if we differentiate tan cubed theta, okay, so if we differentiate tan cubed theta, we get from the chain rule, it's going to be 3 tan squared theta. Okay, and then we need to, so that's already done. So now we have to differentiate tan theta, and the derivative of tan theta is sec squared theta. So this is very similar to what we have. We have sec squared theta tan squared theta. So what we have to end up doing is divide tan cubed theta by 3. Okay, and that is therefore our derivative. Okay, so this, the derivative here, let's move this. So the derivative of this part right here becomes tan cubed theta over 3. Okay, so our derivative of sec 4 theta the total derivative is equal to tan cubed theta over 3 plus tan theta plus our constant, because there are no bounds of integration. Okay, so just to reiterate what we did here, we saw that the derivative of tan theta is equal to sec squared theta. So if we have tan cubed theta, we get the derivative, the derivative of tan cubed theta is equal to 3 tan squared theta, and then from the chain rule, we look at the derivative of tan theta, which is sec squared theta, and that gives us what we need. Yeah, so that's how we got that, and you can see why it's worth 7 marks, because there was a decent amount of work that needed to go into that. Okay, so with that, that question is done. Okay, and then we need to find the following integrals. So the integral, so 9.2 we can do here. We want to calculate the integral of sine x plus cos x all squared dx. Okay, so what we're going to do is we're going to multiply this out. So this is equal to sine squared x, so the integral of sine squared x plus 2 sine x cos x plus cos squared x dx, okay, which is equal to, okay, we know from our identities that sine squared x plus cos squared x is equal to 1, so it's equal to the integral of 1 plus, okay, and another identity, we know that sine x cos x is equal to, 2 sine x cos x is equal to sine 2x. Okay, so that's what we have here, another identity which is found on our formula sheet. So we can replace 2 sine x cos x with plus sine 2x. Okay, and we're left with that dx. Okay, then the integral of 1 is x, the integral of sine is minus cos, and we have 2x, so we need to divide by 2. Okay, and again we're left with an integrating constants because there are no bounds of integration which were given, so that is our answer. Okay, so a little bit of trig identities in these questions. So yeah, I hope you guys were able to follow that. Okay, and then the last question, let's see, question B, and that is also worth 8 marks, so quite a lot of marks allocated to that question. Okay, the next question, we have the integral of x minus 2 times the square root of 3x squared minus 12x plus 5 dx. Okay, so for this question, what's important to realize is we can use a very useful trick, which is for our u substitution. Okay, so basically when we can use this is when we can see that the derivative of something, in this case the inside of this, gives us our x's. So the derivative of x squared gives us an x, and the derivative of x gives us a constant, which is what we need here. So often then we can use u substitutions. Okay, so what we're going to say is that u, so for this question, let u equal 3x squared minus 12x plus 5, then du dx, or the derivative of u in terms of x, is equal to 6x minus 12. Yeah, but a more useful way is to pull out a 6, so then du over dx is equal to 6x minus 2, which is what we have right there. So that means du is equal to 6x minus 2 dx. Okay, and with u substitution, we're going to replace, let's underline it in a different color, this term and this term with, so these two terms. So we've got those two, so we need to get rid of the 6, so we divide by 6. Okay, so what we're going to be left with is du over 6. Okay, and now we can substitute stuff back in. Okay, so the x minus 2 dx get replaced with du over 6. I'm going to do it like that. Okay, and then we're left with the square root, and that's just u. Everything here is just equal to u, so that's going to be u to the power of a half. Okay, so what we're left with is u to the power of a half times du over 6, so that we can simplify that as 1 over 6 integrate u to the half du. Okay, and this is a pretty simple integral, so what we have is 1 over 6, the integral of u to the half is u to the 3 over 2, and we need to, for the chain rule, we need to multiply this by the inverse of our exponent, which is 2 over 3. Is that correct? Yes, that is correct. Okay, and once again, we are going to have plus some integrating constant. Okay, so now what we have is this cancels with that, becoming a 3, so we're left with 1 over 9 u to the power of 3 over 2 plus c. Okay, 1 over 9, sorry about that, 1 over 9, and then we replace a u with our substitution, which is 3x 3x squared minus 12x plus 5 to the power of 3 over 2, and we're still left with our integrating constant. Okay, and that is the final answer. And we get a nice 7 marks for that question as well. Okay, so lots of marks there, a little bit of thinking here and there, especially with the trig substitutions and identities and the identification of this u substitution. So I hope you guys found this useful, and thanks for watching, guys.